Okay, so this is reporting on a project which we're calling Advanced Number Sense. It's online materials that try to fill in gaps that incoming college students have in their math preparation. And my two co-PIs are Dr. Mary Legner of Riverside City College. Hi, Mary. And Kelly Wasserman, also of Cal State San Bernardino. And the project is funded by the Learning Lab project from the state of California, and it was supported initially by a kind of a seed grant from GIA, and it grew into this much bigger project that got funded by Learning Lab and by RCC and Cal State San Bernardino. One of the impetuses for this was that in 2018 the whole state made a big move to kind of get rid of developmental math as we know it. And the reason for that was that it had turned into kind of an endless, you must do this before you get to take a college class, and it was kind of aimed at like Algebra 2 and things leading to Algebra 2, because at the time there was an Algebra 2 prerequisite for entry-level Cal State courses. So everything changed, and community colleges are allowed more developmental courses because they are open enrollment, but still there's quite a limit on what students can be required to take. So the alternative is to use a co-requisite approach, which means to enroll students in a college level credit-bearing math class and provide them with support on the side, such as a stretch course that takes more than one term, or a support lab from 1 to 3 units, and these should be linked to the main course that they have. And so it's a big change from the Algebra 1 for everybody that we used to have. Okay, so while the structure has changed, most of what I've seen is not asking about what is it that we're teaching. And so often you hear about innovative ways to deliver the same old material, and the same old material needs some work. And so the question is, what kind of topics and concepts and maybe non-cognitive things will help students succeed in the new format courses? So, confession, we are all mathematicians, and so our main interest is math, juicy math problems. Oh, that's so great. And of course we care about students too. And one of the things I've noticed about GIA and this process, this conference, is that the people usually involved in this are mostly about getting things done, and often on a huge scale. And so this doesn't quite do the same thing as that, but I'm looking forward to working with them to make things happen in the math department. Okay. So the big problem seems to be not algebra but number sense, which seems like, well, didn't they get that in elementary school? What is number sense at the college level? How can you detect it or the lack of it, and can you teach it? So we started off by doing some kind of short pre-tests for students in first year college math courses, and the test had 3 questions, and I'll show you some student work. So the first question was, there are 12 inches in a foot. How many square inches in a square foot? And so the first answer, the student says, 12 inches is a foot, but I don't know what a square inch is. So I'm assuming this is 12 times 2, maybe because 2 is because of squaring, you raise to the 2nd power. And so that in case it would be 24. That's actually not an atypical answer, unfortunately. The second answer I selected was a diagram showing a square that's 12 inches on a side and computing its area, which is just right. Second question was asking for a mental calculation and asking for an approximate calculation. So the population of Los Angeles is 4.058 million. The population of Lompoc is 42,635. About how many times as big is Los Angeles compared to Lompoc, or Lompoc, I think, and explain why you did it. And so this should be something that should not involve really complicated stuff. Just, tell your grandmother, she should understand. Okay, so the first answer, the person says 2 times as big, and they subtracted because it's bigger. And if you'll notice that they subtracted 4.0580, just ignoring the million. So the 4 is in the ones place, comparing with the 5 individual people in the ones place for Lompoc. So this has a lot of things wrong with it. Okay, second answer is a correct answer, about 100 times as big. I just multiplied Lompoc's population by 100 to make it something about 4.2 million. Okay, let me just show you quickly a slide from the Common Core Standards, which we use in California. This is grade 4. Interpret a multiplication as a comparison. 35 is 5 times as many as 7, and 7 times as many as 5. That's kind of the basic idea here, which that first student didn't seem to be able to use in this problem. So the question is, if this is a 4th grade standard, is this a 4th grade problem? Clearly not. 4 point whatever million. And so this is kind of getting at the, what do you mean by college level number sense? So students need to know these basic concepts from sometimes elementary school, and often it's just middle school, but they need to know how to do it and with complicated questions and in adult situations. The third question was, write 0.05% as a decimal without using a percent sign. So when you're going to do a percent, you move the decimal place and multiply by that decimal. So the first person says 0.05. Okay, hold on. I mean, it's a decimal without the percent sign, right? Isn't this correct? Please tell me if it's not. So unfortunately, we don't know the student, so we can't. The second student knew it was about moving the decimal place, but moved it in the wrong direction. And the third person also moved the decimal place, sort of not clear how. And the fourth person actually moved the decimal place in the correct direction, the correct number of places. So this is the kind of questions we're talking about. Things that seem to be middle school level, but often are involved in adult things. This is one of the student actors in our videos. So we have him thinking, in college they expect us to know things that I don't think I ever learned. So it's not clear that a lot of this stuff was explicitly taught or taught in a way that students could use it at higher levels. So maybe it wasn't taught, or maybe students somehow just didn't think it was important. We don't know why. Why didn't it get taught? Whatever, the students somehow are not using this. So moving along. So in the data, so this is more about who was doing this test. So this was the Early Start program at Cal State in summer 2019. This was an in-person program, 5 weeks. And evidently they did learn some of it from their course. The first class, they almost doubled their performance. And the second question, the comparison, they didn't improve very much. That was actually a much harder question than the other two. And then the third problem, it was maybe remember how this works, so they improved a lot. But we're still only up to a little over half, so I think that's not really acceptable. And here are some first-year courses in the fall of 2019. So on some of these tests, some of them they declined on the comparison problem. Okay, so that's just establishing that there is a big problem. The project was supported by the California Education Learning Lab, also from GIA. So what we did was to create 10 modules that are on the free platform Myopenmath.com. It's free to students and to teachers, so students could use this independently, for example, if you have some tutoring students. And teachers can use it as teachers. They can create classes on on the platform that include a grade book, and they can really keep track of what their students are doing. Each module contains a short pretest, a short video, which you can look at yourself later if you'd like. There is text to read, like a section of the textbook. There are problems for learning, which is practice problems like homework, and they can do them as many times as they want. And then there's a post-test, which is at this point just the same as the pretest. So if you're interested, you can make yourself a student account, myopenmath.com. Okay, so the topics, I think I'm just going to switch to the actual course. Let me jump to the next slide. So not only mathematical topics, but there are some habits of mind that we like to emphasize that often we see our own students not using. So for example, estimating. Before you actually do the problem, just estimate like about how big will the answer be. Once you finish it, check with your final answer, does this make sense? Like -3 million is probably not going to be a sensible answer in some questions. One thing that's neglected a lot in math classes is being clear about quantities and units, and especially calculations that use units, also known as dimensional analysis. Using techniques that are not algebra to understand the problem. And these are typically are tools that could be used in middle school, but they are especially useful even at the college level. So tables and double number lines are some of the ones we like. Expressions. Instead of just writing an answer as a decimal and typing it into the system, this system allows you to code problems so that the answer can be entered as an expression. For example, 17 divided by 4.8 to the third power. This is actually a kind of algebraic habit of mind, and instead of simply calculating yourself on your calculator. It's also what you need if you're going to use things like spreadsheets or other mathematical software. Critiquing others' reasoning. So while you can't have this online in a self-paced thing, we try to provide some opportunities. Critiquing is multiple choice questions with, here's a problem, comment or which students had a correct answer and correct reasoning, choose all that apply. And so they have to really think about each student's answer and what makes sense. Okay, so I'm going to switch over to, before I switch, we have videos. So we use some student actors. They're not actually math students, they're theater majors, but they do a really good job. And the videos tend to be contextual situations. They're a problem that has a bunch of different mathematical aspects to it. Even say, how many beans are in this jar? You'd be surprised at how much math is in that problem. Okay, so let's move to Myopenmath. This is the demo course. So the bars that are in yellow are the modules. And actually there's some extra stuff that's eventually going to get in there, but not ready for prime time. So the topics are estimating and counting. So the subtext of this is place value, as we saw was an issue in the comparison of populations problem. Quantities of units, that's up front because it's really important. Lengths and measurements. One of the things that's in there is reading a ruler, which is really about understanding number lines. Multiplicative reasoning includes like what are some meanings for multiplication and division and where is it used. And it also includes addressing the misconception that multiplication always makes things bigger and division always makes things smaller. An unfortunate holdover from working with whole numbers. Additive reasoning is more about subtracting than adding, and also has a comparison between adding and multiplying, subtracting and dividing. Spreadsheets, I love spreadsheets. But this is mostly about expressions. It used to be called expressions, but spreadsheets are a really useful thing for doing both math and other things. The next unit is kind of a prerequisite for the following one in case students need some extra work before they do dimensional analysis. How to do calculations that include units as part of the calculation, not simply tacked on at the end. Rates are about things like miles per hour, dollars per ounce, and things like that. And then finally an advanced percent module, not simply how to do a percent of, but various ways to use percent increase, percent decrease. It's surprising how much of it there is in advanced percent. I picked out some problems. Let's see, I think I'm just going to go to the teacher's view. So when you're entering this as a student, you don't see this. So I picked out some of my favorites. These are descriptions for the coders. Okay, well, maybe we should start with the population density of Los Angeles. So this is not comparing the population, this is from the rates unit. The estimated population was this number. Its area is that number. What is the population in people per square mile? So this is kind of a computational problem. And in fact, this one does not have multiple answers. Fortunately, it does not require this amount of precision for your answer. It will accept, I think, 3 significant figures as correct. Okay, that was sort of a basic question. Let's go back to the beginning. Quantities, one of my favorite important units. Okay. So, left column, oops, not right. So the top are a number of quantities, just kind of randomly chosen quantities, or they might not be quantities, or they could be attributes, or they could be. Okay, so the choices are, well, here are all the things, and what types of things are. It could be a unit of measure, it could be a quantity, it could be a non-quantitative attribute, or it could be none of these things. So miles per hour is actually a unit. So that would be A. Time spent working is a quantity. Gender is not a quantity. It's a yes or no question, so it's a non-quantitative attribute. Breed of dog, another non-quantitative attribute. Depth is a quantity. Sense, photograph of a dog is not even an attribute, it's just a thing. Sense is a unit. Circumference is a quantity. Let's see if I got them right. So this is what a student will see when they do this. And it's green. I got them all right. With a little encouraging remark. Okay. Here's an example of units, but it's also about estimating. So here's somebody that's on a trip, and she changes all her Cordobas, the Nicaraguan money, for Canadian dollars. So these units were chosen, so they're probably not familiar to most people. So we don't really know how big any of these are. But we do know that 28,000 and change Cordobas is worth 1,000 and change Canadian dollars, which is a bigger unit of money. So the naive person will say, oh, this is a bigger number, so the Cordobas are bigger. But no, it takes more of them to make the same amount as 1,000 Canadian dollars, so the dollar is worth more. So that's kind of one of the ingredients of estimating and does your answer make sense, that I don't think I've seen anything like this in existing curriculum.
I have a quick question.
Yes.
If the student doesn't understand that, can they click on that key and explain a little more to check their understanding?
So sometimes there are, help or hints. I'm not sure that this one has one yet. There actually in the unit there are some easier questions that have more familiar units like dollars and pesos or things like that. So this is one of the more advanced ones after they've kind of worked through the familiar units. Let's look at this one. This is a more long-winded one. And actually we are still working on these problems, so we're trying to add more hints and support for students that don't know what to do. Okay, so here's a word problem, and the point is not so much to solve the word problem is to give students an example of how to set up such a word problem. So it's a guess and check table that this person, Alondra, has supposedly set up. So so we know how much the total was on her bill. The bill said $225 for materials and the rest was labor, and the hourly rate was $79 per hour. How many hours of labor were needed? So this is kind of an Algebra 1 technique, or maybe even middle school. So we need to choose what quantities go in each column. And they're the same 5 choices here. So what are these numbers? Maybe if we're not sure, maybe we should look at these. $79 and 10 hours. That means that this would be the cost of labor. This would be the number of hours. Let's see, $225. Oh, that's how much the materials cost. And the total. Oh, there's the total at the very end. So that's the total cost. And now we also need to choose units, 13 or 10 or 13 hours, and all the rest are dollars.
If I can make a recommendation, I think it would be better for the table to be set up as the problem is being solved. So, I mean, the student can take several approaches, right? But one approach would be definitely starting with the total. So maybe the first column could be the total. And then, well, what is extra here that is not dealing with the question, right? The labor of our laborers. So 225 materials. So maybe the second column could have been 225. And what I'm suggesting is that this table, which is a great idea, by the way, it's just that if we can show the flow of the problem solving method on a word problem.
Yeah.
So they start learning.
Actually, this is a standard technique called the guess and check table.
Yeah,
and
no, it's
so the
fine.
First column is your guess.
No, I understand, but the guessing work that you're doing is still also something that you do in solving a word problem. So if you get them already involved in solving it in a process, they're internalizing the process mode as well.
Yeah, so we could probably do some variations on this, but this is a particular technique that was done on purpose. Okay, and then it also asks which are variable and which are constant. This is kind of pre-calculus sort of question. So let's see, what is variable? Cost of labor, but not the cost per hour. Those are all variable. Which are constant? Cost per hour of labor and cost of materials. And what's the answer? Just make sense of this table. How do we get the answer? Actually, here's the total. We're asked how many hours, so that would be 13.5. And I think I got all these right. Yay. Okay, so there's a way to do fairly complicated questions here, and some of them are tutorials, some of them are kind of walking you through a problem like this. Does anybody have let's see, maybe let's look at the critique reasoning type of problem. Okay, so Brandon did a problem that asked for the surface area of a cone. He got the answer of 146.2 cubic inches. And it says the number part is right. What are the correct units? Choices: the unit cubic inches is correct because cones are 3-dimensional. That's not actually right. The unit is not correct because he should have used the metric system. No, you can use any system you like. And here it says it's not correct because it should have been inches or centimeters, not cubic inches. And let's see, And the last one is correct. The surface area is in square inches. Okay. And so these problems tend to have answers that we have gotten from students, and so we know that some people will think that.
There's a question in the chat. The
Okay.
person who has an audio problem.
Okay.
What happens if the answer given is incorrect?
If the answer is incorrect, and okay, so thanks for that reminder. So if I chose maybe let's choose two of them, one right, see what happens. So yellow means that it's partly correct. And so you get another chance, depending on how it's set up. There are settings for the instructor. You can set them to give no extra chances, as many extra chances as they want, and so on. Okay, so let's try again. Let's see. Okay, maybe just this one was correct. Oops, let's see. Oh, the answers got changed, the order got changed, so that was correct. So what if I did this one? Okay, maybe that one needs looking at again. This should be incorrect. This is still under development. Okay, 3 more minutes left for this session. That was several minutes ago. So since we had some questions within it, I guess that's it for the question session. And let's see. So actually, let me just say one more thing, that because of COVID, implementation and using this in the classroom is quite a mess, because instructors don't have time for doing extra stuff, and students are, they're kind of all over the place, even though they need this more than ever. So let me end there.